7-2 division properties of exponents. So in the last section, we multiplied monomials using properties of exponents, and now we're going to divide monomials using properties of exponents, and then simplify expressions containing negative and zero exponents. What happens if your exponent ends up being zero or negative? We're going to talk about that. So the vocabulary that we're going to discuss is zero exponent, negative exponent, and then order of magnitude at the end. So the tallest redwood tree is 112 meters, or about 10 squared meters tall. The average height of a redwood tree is 15 meters, so the closest power of 10 to 15 is 10 to the first. So an average redwood is about 10 to the first meters tall. The ratio of the tallest tree's height to the average tree's height is 10 squared over 10 to the first, or 10 to the 1. This means that the tallest red tree is approximately 10 times as tall as the average redwood tree. So we can use the principles for reducing fractions to find quotients of monomials, like 10 squared over 10 to the first. In the following examples, look for patterns in the exponents. So if I have 2 to the 7th over 2 to the 4th, 2 to the 7th means multiply 7 factors of 2. 2 to the 4th means multiply 4 factors of 2. Since they're in a quotient, I can cancel common factors, so I cancel how many? Well, 8 of them get canceled, but there's 4 sets that get canceled. And so that leaves 2 times 2 times 2, or 2 cubed. What do you think we did? What's the shortcut there? Well, how about t to the 4th over t cubed? Well, you have 4 factors of t over 3 factors of t. There's 3 sets of common factors, so you could cancel those out, leaving just t. So these examples demonstrate the quotient of powers rule. To divide 2 powers with the same base, you just subtract the exponents. So if I have c to the 11th over c to the 8th, you don't have to necessarily write out all 11 c's, all 8 c's, then cancel out the common factors, and then have 3 c's left over and write it as c cubed. You can just remember that when you divide like bases, you subtract the exponents. So 11 minus 8 gives you c cubed. That's like the shortcut. Okay, so let's simplify this, and assuming that the g or the h doesn't equal 0. Okay, so you would have g cubed h to the 5th over gh squared. So that's going to be, you can group the powers with the same base. So g cubed over g, h to the 5th over h squared. Then you could write g to the 3rd minus 1 times h to the 5 minus 2. Where did this 1 come from? Remember, if a variable or a number doesn't have an exponent on it, it's understood to be a power of 1. So g squared h cubed is my final answer. All right, here's 2 for you to try. Go ahead and pause the video. All right, we're back. 1a, I can group the x cubed over x squared and the y to the 4th over y. Remember, that's understood to be y to the 1. So I can write that as x cubed minus 2. And y to the 4th minus 1, which is going to give me x to the 1st, y cubed. Boom. The next one I can write as k to the 7th over k to the 5th times m to the 10th over m cubed times p over p. So you'd have k to the 7th minus 5 times m to the 10th minus 3 times, what's p over p? They just cancel each other out. It's technically understood to be 1. That's a multiply right there. So you would have k to the 2nd, m to the 7th times 1, or just k squared m to the 7th. Okay? Pretty cool stuff there. I know, it's awesome. All right, we can use the product of powers rule to find powers of quotients for monomials. Look at the pattern here. If I have 3/4 cubed, that means 3/4 times 3/4 times 3/4, or 3 times 3 times 3 over 4 times 4 times 4, which is 3 cubed over 4 cubed. If I have c over d squared, that means c over d times c over d, or c times c over d times d, which is c squared over d squared. All right, so to find the power of a quotient, find the power of the numerator and the power of the denominator. So if I have 3/5 to the 4th, that just means 3 to the 4th over 5 to the 4th. If I have r over t to the fifth. That means r to the fifth over t to the fifth. Let's try this one. 3p cubed over 7 all squared. So the power of a quotient property says I can square the numerator and square the denominator. So 3p cubed quantity squared over 7 squared. Then I can use power of a product in the numerator. Since it's 3p cubed quantity squared, I can square each factor. So 3 squared times p cubed squared. And then simplifying that a little bit, I would get 3 squared is 9. P cubed squared, multiply the exponents, you get p to the 6th, and 7 squared is 49. Can't simplify this fraction because it doesn't reduce. The only thing that reduces 9 is 3, and 49 would give you 7s. So nothing cross cancels. So it's in simplest form. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. 2a, you would have 3x to the 4th cubed over 4 cubed, which would give you 3 cubed x to the 4th cubed over 4 cubed. So 3 cubed is 27. X to the 4th cubed is x to the 12th over 64. Boom. This one would be 5x squared y quantity squared over 6 quantity squared, which would be 5 squared x squared squared y squared, like that, over 6 squared. Oops. There we go. So 5 squared is 25. X squared squared would be x to the 4th. Y squared would be y squared. And 6 squared would be 36. Again, this fraction is in simplest form. So go from there. Next one, you would have 2y squared squared over 3z cubed squared. So that would give you 2 squared y squared squared over 3 squared z cubed squared, which would be 4y to the 4th over 9z to the 6th. Okay, and then the last one, you have 4x cubed cubed over 5y to the 4th cubed, which would be 4 cubed x cubed cubed over 5 cubed y to the 4th cubed. So that'd be 64x to the 9th over 125 y to the 12th. All right, hope you did well there. Let me know if you have any questions on that one. All right, a calculator can be used to explore expressions with 0 as the exponent. There are 2 methods to explain why a calculator gives a value of 1 for x or 3 to the 0 power. So for example, if I bust out my handy dandy calculator and I do 6 to the 0 power like that, you're going to get 1. If I do 8 to the 0 power, you're going to get 1. If I do a large number like that to the 0 power, guess what you get? 1. All right, well, let's check this out. So 2 different methods get the same answer. If I do the quotient of powers, 3 to the 5th over 3 to the 5th equals 3 to the 5 minus 5. 3 to the 5 minus 5, you subtract the exponents, you get 3 to the 0. The other method is to write it out. 3 to the 5th over 3 to the 5th. You have 5 3s over 5 3s. They all cancel out. The answer is not 0. Think about it. If you have 4 divided by 4, that doesn't just go away. 4 divided by 4 is 1. So you would actually have 1 times 1 times 1 times 1 times 1, and you get 1. Well, since I did the same problem in 2 different ways, those 2 answers must mean the same thing. So since 3 to the 5th over 3 to the 5th can only have 1 value, we can conclude that 3 to the 0 power equals 1, and a 0 exponent is any non-zero number raised to the 0 power. It has to be a non-zero number. You can't do 0 to the 0 power. All right, you get into that in like calculus. Weird stuff goes on with that. All right, any non-zero number raised to a 0 power is equal to 1. So a to the 0 equals 1. So you know, if you have just a number to the 0 power, it's 1. If you have a fraction to the 0 power, it's 1. If you have a fraction with numbers or variables to a 0 power, it's always going to be 1. Let's simplify this and assume that none of the denominators equal to 0. This whole big mess is raised to the 0 power. Guess what the answer is? 1. Because anything to the 0 power, as long as itself is not 0, is 1. How about this? X to the 5th, y to the 0 over x cubed. Well, the y only has the 0 power, so that's going to be equal to 1. And then I can use the quotient property of exponents for the x to the 5th over x cubed. And 5 minus 3 is 2, so it's just x squared. All right, here's a couple for you to try. Go ahead and pause the video. All right, we're back. So 3a is going to be b to the 4 minus 2 times c to the 2 minus 1 times d to the 0 is just 1. So you would have b squared c. This one, it's that whole entire expression raised to the 0 power. The answer is just 1. Pretty cool, huh? Like it when it works out like that. All right, that's it for this video. Please stay tuned for the next one.